Episode 39, AI Hallucination Detection and Mitigation. How Senior Engineers Build Reliable, Trustworthy AI Systems in Production. Welcome back to Agentic AI World. I'm your host, and today we're tackling one of the most critical challenges in production AI, hallucinations. If you're preparing for senior AI engineering interviews, this topic will come up, guaranteed. Let's break it down so you can answer with confidence. First, what exactly is a hallucination? An LLM hallucination is when the model generates a response that sounds plausible but is factually incorrect, invented, or unsupported by the source context. The model isn't lying. It's pattern matching over its training distribution and producing statistically likely tokens, not verified facts. There are two main types. Closed-domain hallucinations. The model ignores or contradicts explicit information in the provided context. You gave it a document, but it made something up anyway. Open-domain hallucinations. The model generates content based on its training weights that doesn't match real-world facts. Wrong dates, wrong names, wrong statistics. Both are dangerous in production. In a legal AI system, a healthcare chatbot, or a customer support agent, hallucinations aren't just embarrassing, they're liability. So why do hallucinations happen? 3 root causes. 1. Training data quality. If the model saw conflicting or incorrect information during training, it learned to reproduce those patterns. 2. Overconfidence in generation. LLMs are trained to produce fluent, complete answers. They don't have a built-in, I don't know mechanism. Silence isn't in the output vocabulary. 3. Context window limitations. When the relevant fact is far from the current generation point, attention scores dilute and the model fills in gaps. Understanding the root cause helps you design targeted mitigations, exactly what interviewers want to hear. Now let's talk detection strategies. This is where senior engineers differentiate themselves. Strategy 1. Groundedness scoring with an LLM judge. You take the model's output, the source context, and a second LLM prompt asks, is every claim in this answer supported by the context? Score from 0 to 1. Tools like Ragas, TrueLens, and Langsmith implement this pattern. It's not perfect, but it catches obvious fabrications. Strategy 2. Self-consistency checks. Run the same prompt multiple times with temperature greater than 0. If the model gives wildly different answers, it's likely hallucinating. If answers converge, confidence is higher. This works well for factual lookups. Strategy 3. Retrieval citation verification. In RAG systems, every claim in the response should map back to a retrieved chunk. At inference time, parse the output, extract claims, and verify each claim against the source chunks. Flag any claim without a supporting passage. Strategy 4. Semantic similarity threshold. Compare the generated responses embedding against the embeddings of the retrieved documents. A low cosine similarity is a red flag. The response has drifted from the source material. Strategy 5. Confidence calibration models. Fine-tune a small classifier on your domain to predict whether a given model output is likely hallucinated. Train it on labeled examples from your QA team. This is expensive up front, but very powerful at scale. Now for mitigation. Detection tells you there's a problem. Mitigation prevents it. Mitigation 1. Constrained decoding. Force the model to answer only using explicit quotes or passages from the source. Prompts like, answer only using information from the context below. If the answer is not in the context, say I don't know it. This is the cheapest, highest leverage mitigation you have. Mitigation 2. RAG with re-ranking. Bad retrieval is the #1 cause of closed-domain hallucinations. If you retrieve the wrong chunks, even a perfect LLM will hallucinate. Use a cross-encoder re-ranker, models like Cohere re-rank or Colbert, to ensure the top chunks are actually relevant before passing them to the generator. Mitigation 3. Fine-tuning on domain data. For critical domains, fine-tune the model on high-quality, verified examples. This teaches the model to stay within domain boundaries and recognize when it should defer to retrieved context. Mitigation 4. RLHF and constitutional AI techniques. Train the model to reward accurate, grounded responses and penalize fabrication. This is expensive but shifts the model's base behavior. Mitigation 5. Human in the loop for high-stakes outputs. For medical, legal, or financial responses above a certain risk threshold, route to a human reviewer before delivery. This is not a failure, it's responsible engineering. Let's talk system design. If an interviewer asks you to design a hallucination-resistant AI system, here's the pattern. Start with retrieval quality. Use hybrid search, BM25 plus dense vector search, with a re-ranker. Ground truth starts here. Then constrained generation. System prompt enforces citation behavior. Temperature is low, 0.1 to 0.3 for factual tasks. Then a groundedness evaluation layer post-generation. LLM judge or similarity threshold. Then a confidence router. High confidence, serve immediately. Medium confidence, append a disclaimer. Low confidence, escalate to human or return, I don't know. Finally, logging and drift detection. Every output with low groundedness scores feeds back into your evaluation dataset. You retrain your judge, improve your retrieval, and close the loop. That's a production hallucination mitigation stack. Interview question to practice. You're building a customer support AI for a financial services company. The AI is sometimes giving incorrect account information. Walk me through how you diagnose and fix the problem. Model answer structure. Step 1. Diagnose retrieval. Are the right documents being retrieved? Check recall metrics. Add re-ranking if needed. Step 2. Audit prompts. Is the model being explicitly constrained to source material? Tighten the system prompt. Step 3. Add a groundedness evaluator. Automatically flag low confidence responses. Step 4. Implement a human escalation path for flagged responses. Step 5. Build a feedback loop. Flagged responses become training data. The system improves over time. Key takeaways. Hallucinations happen because LLMs optimize for fluency, not accuracy. Understand the root cause, bad retrieval, overconfident generation, or context dilution. Detect hallucinations using LLM judges, self-consistency, citation verification, and semantic similarity. Mitigate using constrained prompting, better retrieval, fine-tuning, and human-in-the-loop for high stakes. Design systems with a groundedness evaluation layer and a confidence router. Always close the loop. Flagged outputs improve future performance. That's episode 39. If you're preparing for senior AI engineering roles, master this